Okay, this is Mr. Ashton going through PPE3, so I'll try and show you how to do the questions that you may have struggled on in exams. Make sure you're only covering questions you didn't like in the exam. Don't waste your time focusing on things that you can already do. Okay, so first question, you're going to get one of these and make it really nice and obvious now the mark schemes where they're coming. I've got to make sure my work is organised correctly here, okay, because otherwise I'm not going to get 2 marks. Okay, now I'm going to show you the way that I do it. It says 25 millilitres of milk or water is approximately 1 fluid ounce. So I'm going to say 1 FO, fluid ounce, is equal to 25 millilitres. Now, in terms of what it says in the question, Owen works in a school kitchen. He used the recipe information for pancakes shown above. He has measured out the plain flour, milk and butter and placed them with the eggs in a large bowl. He measures out 150 fluid ounces of water to add to the pancake mix in his bowl. So I've got to change 1 into 150. Now, I'm not actually going to rush this. I'm going to take my time. I'm going to times that by 5 because I can times by 5 quite easily. And whatever I do to one side, I need to do the other side. So 25 times by 5 is, well, 25, 50, 75, 100, 125. I still need to turn that into 150. I'm now going to change it into 15 by timesing both sides by 3. So 15 fluid ounces must be 125, double it, 250, add on 125 would be 375 millilitres, and then to get the 150, which is what they wanted there, that will now be that. That is timesing by 10, isn't it? So times that by 10 means times that by 10. So that is 3,750 millilitres. Okay, now because I get marks for my communication and organisation and accuracy in my writing, I'm going to say changing given fact, I suppose, given useful information, changing given fact to 150 fluid ounces, 150 fluid ounces given in question. Okay, that's what I'm doing here. So just explain to someone, just don't have calculations popping up out of nowhere. Now, you were told here that he already has the flour, the egg, the milk, and the butter. It's already in one bowl. That's what it says by here. Okay? We haven't got the water. Now, we know that 37.5 millilitres is enough to make 4 pancakes. So I'm going to say 35.7 millilitres equals 4 pancakes. Now, I haven't got 37.5. I've got to get 3,750. And they're hoping you're going to spot a link here. Now you can do this in 1 step. I'm going to do it in 2. I'm going to times this by 10 to get rid of the decimal, and that will give me enough for 40 pancakes. And then I'm going to times it by 10 again to get enough for my amount of water, which would be 400 pancakes. And that would be my final answer. So I'm going to make sure that stands out very, very clearly. Again, just going to reference what I'm doing here. Why am I doing this work here? This is changing recipe to the amount of water we have. So you can see that clearly to the amount of water we have. Okay, so that's how I would do it personally. Question 2. It says Derek works for a company which designs and fits kitchen cupboards. Kitchen cupboards and worktops are usually measured in millimetres. Okay, a rectangular worktop needs to be covered in a special varnish. The worktop measures 3,000 millimetres by 700 millimetres wide. Calculate the area. Unfortunately for us, not in millimetres but in metres squared. So I'm going to change that into metres. So 3,000 millimetres would equal 300 centimetres, which is equal to 3 metres. 700 millimetres is equal to 70 centimetres, which is 0.7 metres. So to work out the area, it's going to be 3 times by 0.7. Well, 3 times by 7 is 21. So 3 times by 0.7, which is 10 times less, must be 2.1 metres squared. Okay, the next one, now I actually set this up as an equation, this bit here. It says a kitchen cupboard in the shape of a cuboid has a capacity of 420,000 centimetres cubed. Internally, the cupboard measures the following measurements, and it's 60 times by 70, but it doesn't tell us what the height is, so I'm going to call that H for height. So I know to work out the volume of that thing, I do 60 times by 70 times by the height, and I know that should come to 4,200. Wow, one more, there we go. Okay, what I'm going to do next is I'm going to divide by 10 this side, so I've got to take off a 10 that side, and I'm going to divide this side by 10, so I've got to take a 10 off that side as well. 6 times 7 is 42, times by h is 42 times h, that equals 4,200. I then want to divide this side by 42, because I've taken the 42 times by over, and then I cover up the zeros. How many 42s go into 42? 1. And then how many zeros appear from behind my thumb? 2. So the answer would be 100 centimetres. Okay. Question 3, or part C. Now, it's very, very, very important. I saw a really good solution when I was marking these, and it did the following. It said upper bound by here, lower bound by here, and then it had wall and it had worktop. Okay, now where it says measure to the nearest 1 centimetre, they might just say measure to the nearest centimetre. Now it's very, very important that if it says measure to the nearest centimetre, to the nearest 1 centimetre, whatever, that you divide that number by 2. So 1 centimetre divided by 2 comes to 0.5. To find out the upper bound of the worktop, I need to add on 0.5 to the 301. So it would be 301.5. To find the lower bound, I would just subtract it from 300, which would give me 299.5. Okay? Now, I know that technically speaking, round to the nearest 1, that would round to 302. However, oh, hang on, I've made a mistake. That's not 299, is it? That is 300.5. Okay? In terms of, I made a mistake in both of them, I think. 300.5 centimetres. In terms of the next one, it says that this was measured to the nearest 5 centimetres. So that is 5 centimetres that we divide by 2. Now that would come to 2.5 centimetres. So to find the upper bound of the wall, it would be 605, add to the 2.5, so that can be 607.5 centimetres. And then to find the lower bound, I would take off the 2.5 centimetres, so that would be 602.5 centimetres. Okay? Now in terms of what I was trying to say before, now I've got the right answer here, if I was to measure to the nearest 1 centimetre, obviously that would round to 302, but we recognise the upper bound, you can actually never quite get there, whereas the lower bound, you can actually have that number and it would round correctly to 301. Now just writing that table, that would have picked you up 2 marks. It then says explain why, unfortunately he finds the worktop does not fit, explain why this might have happened, and state the greatest possible difference between the lengths of the walls and the lengths of the 2 worktops. So in terms of what the issue is here, it doesn't fit. Now we put in 2 of these worktops, so 2 lots of 300. Now I'm going to look at the worst case scenario. I'm going to say that the worktop is actually as big as it could possibly be. So 2 lots of 301.5 comes to 603 centimetres. Now the wall is actually somewhere between 602.5 centimetres and 607.5 centimetres. If it was 607 centimetres or 607.5 centimetres, that wouldn't be a problem. That's fitting, even if it was measured to the greatest possible thing it could have been. However, if the wall is at the lower bound is 602.5, that worktop is too fit. It's not physically going to fit in. So, explain how this might have happened. It might have happened if the worktops were their greatest value, their greatest possible value, and the wall was the least possible value. Have I answered the question? It says explain why this might have happened. Yeah, I've answered that, and state the greatest possible difference between the length of the wall and the two worktops. So the greatest difference would have been when it was the worktops being the greatest possible. So 603, take away what the wall was, take away 602.5, which is 0.5 centimetres. So you'd have, in effect, a 0.5 centimetre overlap there. Okay? Okay, next question. It says, Lucy has been given pie charts showing a number of computers sold by two different companies. So RG computers, now just on the face of it, it looks like more men buy computers from them, and then more women than men buy computers from them. It says more men buy RG computers than LF computers. Explain how this could be true. Now, on the face of it, it doesn't look like that is true. Okay. However, if this company sells, I don't know, say maybe they sell 10 computers every year, but this computer sells 1 million computers, then more men certainly buy from them. We're not given any numbers with that pie chart. So, what did I say there? I just said we're not told. We are not told how many people buy computers. Okay, that's all they're looking for then. You can put words to that effect, it doesn't matter, as long as you've got something along those lines. Okay. Question 4. Very similar question that's come up in previous years. It says, what is the total stack of 21 cartons? Now, 21 cartons, how would I work that out? I would work that out by saying that I've got all these ones here stacking up to make 1.6 centimetres. So I do 1.6 times by the number in the stack, but that's not strictly true. I wouldn't actually times it by 21 because that base cup is taking up a big stack here. So I do 1.6 times 20, getting rid of the base cup, and then I'd add on the 13.4. Now, if I'm doing this without a calculator, I would times by 10 and then times by 2, because 10 times by 2 is like times by 20. So 1.6 times by 10 is 16. Double that is equal to 32. 32 add 13.4 comes to 45.4 centimetres, and I'm relieved because that is one of my answers. The next question said, now you're quite unlucky if you answer this correctly and you got no marks, but it does say specifically, form an equation and calculate the number of coffee cartons. So in terms of what I did there, I'm going to use this previous example to help me where I use numbers. So it's going to be 1.6 times by, not x, because x is the number of all the coffee cup cartons. I did one less than that, so I need to times that by x minus 1. And then I added on the base carton. Now that will always be 13.4, so that's always going to be add 13.4. And I know that comes to 61.4 centimetres. So that's how you need to do the first bit. I then need to expand that bracket so the 1.6 times by that and the 1.6 times by that. So that becomes 1.6x minus 1.6 times 13.4 is equal to 61.4. You can put this in like column addition or whatever's easiest for you. So 1.6x, so 13.4 minus 1.6. 4 take away 6 you can't do, so you steal one. 14 take away 6 is 8. And then we've got 11, so that would be plus 11.8 is equal to 61.4. I then take away 11.6 from both sides. So again, nothing wrong with doing working by the side here, nothing wrong at all with doing that. So 61.4, take away 11.8. Again, same thing as before, I can't do 4 take away 8, it's a negative, we don't have negatives here. 0 take away 1 I now can't do, so I steal 1 again, so that's going to be 9, and then 4, so hopefully it comes to 49.6. 49.6, well, I need to 49.6. And then I need to divide that by, oh goodness, by 1.6. Okay, well again, I'm going to have to do some more working by here. I want to work out how many 1.6 goes into 49.6. Don't like that question at all. I'm going to times top and bottom by 10. So x would equal 496 divided by 16. And then I'm going to write 16 in here instead. 496. So how many 16s go into 4? None. How many 16s go into 49? So 16, 32, 48. 3. Remainder 1. How many 16s go into 16? 1. So my answer is X equals a stack of 31 cups. Okay. Next question. Okay, I felt this was quite a fussy question. So it was over 2-page spread. Try and move the camera a bit. So it says, by road, and they put that in bold, so it must be important. By road, White Castle, sorry, is 11 kilometres from, I can't even say that word, Castle. Okay, so find them where they are on the map. Here, here. I need to go and measure it, because it says go and work out the map scale is approximately 1 centimetre to how many kilometres by here. So if I go and measure what this distance is, I make that to 8 and a bit. Now, that's going by road though, that's going as the crow flies, sorry. To go by road is obviously going to take longer, but I'm obviously going to try and be a little bit nice to myself here. I don't want to make this say, oh, I don't know, 9.5 or 8.7, I'm just going to say it's 9, okay? So I'm going to put this distance as, well, what is it actually? It's 8.6. You've got to be really, really, really accurate with these things, okay? If you can only be spared like 0.1 of a centimetre either side, so 8.5 and 8.7 would have been fine, but otherwise it would have actually been wrong. Now from there, I'm going to say by road means longer, so 9 centimetres. Now it's a bit of a guess because I don't actually know, I can't actually measure that line there. That's what the numeracy paper is going to look you to do a bit of reasoning. So I want to work out, now I know that 9 centimetres currently, this 9 centimetres is 11 kilometres in real life. I want to work out what 1 centimetre is. So what do I do to 9 to change it into 1? Divide it by 9. Anything divided by itself is 1. But that means I have to divide this side by 9 as well. Okay? Now, how many 9s go into 11? I don't know. So I'm going to do bus stop again. So 11 here. How many 9s go into 1? 0 into 11, 1, remainder 2. Now you need to continue what comes after there, which would be 0.000, you know, forever, potentially, but I'm not going to go forever. I'm just going to do like 2dp, because I can't take forever doing this question. So remainder 2 there. How many 9s go into 20? 2. Remainder 2. Oh, there we go. It's going to be, for me, with what I've done, I've actually got 1.2 reoccurring. Okay? Okay, part B says the treasure has been buried at position X. Okay? X is the position that meets both the following criteria. X is equidistant from Grossman Castle and the one I can't say castle. Now to do that, you need to go and find where it is on the sheet. So it's by here. The way you do that is you get your compass and you make sure your pencil and the compass meet at the same point. If they don't, it will make your life very hard. Now you open your compass to what is obviously more than halfway between the 2 points. So I think that should do the trick for me about there. I put a point on here, and I always move the paper. I never hold the compass by the top black fiddly bit. The closer you are to the point, the less chance you've got of it slipping. Keeping the compass at exactly the same width, I now go and draw an arc from the other side like that. Okay. Now drawing a line where these two things cross, here and here, that, because I know the treasure is equidistant from those two places there, it's got to be somewhere on this line here. Okay? So I've dealt with the first bit. It then says it's also equidistant from White Castle and the first castle as well. So I need to do exactly the same method between those two castles. So where my green line is on my drawing here, I need to bisect that as well. So again, there. And there. Luckily they cross again. If they didn't, I just have to go and make my compass bigger. So where they cross there and there, it's the bold line. So where these two bold lines cross, that must be the position of the treasure. That must be where X is. Okay? So there we go. I've done that. 2 marker there. 2 marker there. Okay, next question. Okay, so let's go there. Yolanda and Emmy set up a gardening business together. They decide to calculate the charge for time that they spend gardening using the following method. Start with a standard charge of 15 quid. Add 10 quid for every complete hour worked. Add an additional 20p for every additional minute worked. Multiply the charge by 2 equals the final charge. Calculate a charge for a gardening job that takes 2¼ hours. Okay, so 15 quid, add £10 for every complete hour work, so that's going to be 10 times by 2. Add 20p. Okay, now, pounds and pence are trying to catch out here. Be careful you don't fall for that. But there's two ways we can write it. I'll put in pounds there. And then 20p. So I'm going to write 20p, but you could write, if you wanted to get it into pounds straight away, you could say 0.20 pounds. That's 20p, isn't it? And then times by now ½ hour would be 15 minutes. Okay, and then it says multiply the total charge by 2. So all of this needs to be times by 2. Okay, there's a little bit of work inside here. 15 plus 20 plus 20p times 15, 2 times 15 is 30, and then add the 0 would be 300 pence. 300 pence would be 3 quid, and then I'm going to get 15 add 20 is 35, add 3 is 38, 38 doubled is £76. Over the page it says, the fourth bullet point in calculating the charge reads, multiply the total charge by 2. Why do you think this? Why do you think it's included in Emir and Yolanda's method? Well, I think the hint's there. Emir and Yolanda, there's 2 of them, because 2 people were working. So I assume it's happened. I might be wrong. That's what I would have thought. Okay. It means the job will be done twice as quickly as well. That's maybe another thing that you could say. And it says writing a formula for the total charge T for gardening that takes H hours and M minutes. Now, I'm going to use this question here, but we've got to make sure we have the same units throughout, okay? So we doubled, and then the 15's always going to be there, because it says they start with 15 quid, okay? Plus, and then it's going to be £10 times by H. Now that's in pounds, so I need to have my other unit in pounds as well. So I'm not going to write, like I did before here, 20 pence, because I just wanted to get a one-off answer. So 0.20 times by M. Now these are going to give me different things here. I'm going to get 30 plus 20H, and then plus 0.4 M, and that will give me the total charge. Okay? And then finally it says, Yolanda notices that there's a problem with the method for calculating the charge. They spent 2 hours gardening for Mr. Rees, and they spent 1 hour 55 minutes gardening for Mrs. Elmander. They paid, Mr. Rees paid less than that person. Now Mr. Rees actually had more time spent on his gardening, an extra 5 minutes, so he should technically be paying more. So if we go and work out what the problem is, the 1 hour would have come to 10 quid. And then the 55 minutes will come to 20p. I'm going to go back to pence here to work, so I think it'll be easier for me. 20p times by 55. 2 times 55 is 110. Add a 0 there is in pence, and then divide by 100 to change it into pounds is £11. So 1 hour is coming out at £10, whereas 55 minutes, which is less time, is coming out at more. So I think I've done the job there. So I'm going to say it is cheaper to do a full hour than 55 minutes, which obviously it shouldn't be. Okay, that shouldn't be the case, so that's what's happened. Okay, the next question was on box plots. It says, looking at the rainfall, which month had the most changeable weather? You must give your answer, or you must give a reason for your answer. So if you don't give a reason for your answer, you can't get it. The one is April here, and the reason why that is because it has a bigger range of higher and lower values. If you look at there, it's the longest one. That tells me it had days where it really, really, really rained and days where it hardly rained at all. So April, as it has the biggest range, and it probably has the biggest interquartile range as well. The smaller your interquartile range, the more consistent something is. So the bigger the interquartile range, the less consistent it is, as it has the biggest range / interquartile range. I could put there as well, meaning less consistent. That's what range means. So you can't see anything I wrote. Okay, well, hopefully now you can pause the video and have a look at what I wrote there. Okay, the next one says, if you don't want much rain, the time to visit the island is June. True or false? Well, let's have a look at June. It's lowest median. Yeah, I agree with that. That's true, because that's the least amount of rain. It's measuring rainfall. The greatest difference in rainfall between the months is between the months of February and March. Well, February and March, yeah, that's a big difference, but I don't think it's as big as this one between April and May, so that's false. The next one says the interquartile range for May is approximately equal to the interquartile range of June. So May and June, yeah, they look roughly the same to me, don't they? The same width there. I can measure the boxes. Yeah, I'm happy with that. That's true. The range of rainfall in February was approximately 15 centimetres. So February it was 30 there and 15 there. Yeah, 30 take away 15. That's true. And then during June, there were more days with greater than 7.5 centimetres of rainfall than there were less than 7.5. So what day are we on, June? 7.4. Well, I think that is exactly 7.5. Well, no, that's 50% above and 50% below because it's measuring the median. So I'd say that's false. Okay? And then part C, it says, in July 2014, the interquartile range of the rainfall was 10 centimetres and the range was 40 centimetres. Is it possible to say whether July has more or less rainfall than June? No, that's not true. And the reason why it's not true is we don't know the average. We don't know the median. But a high range followed by a low interquartile range would suggest some extreme values. Okay, so the smaller the interquartile range, the more consistent it is, and the smaller the range, really consistent. If there's a big difference between these, you'd expect some pretty extreme weather during that time. Okay. Okay, number 8, the tax question. So, the tax question, now it takes a bit of time to read this, okay, so pause the video, have a refresh of the question, try and work out what's going on, and I'll try and start talk you through what I did, okay? Okay, so, the yellow party, the orange party. Now, that's not the word orange, is it? Orange, okay. The yellow party and the orange party. Now, we're quite lucky because we earn, how much, 55,000 euros, that's quite a lot of money. I'm going to represent that in a block, 55,000. Okay. Now we're told in the first party, the yellow party up here, that the personal allowance is 5,000. That means I don't pay any tax whatsoever on the first 5,000. I then pay 10% tax on the first 10,000. Commas to make it easier to write, and that is taxed at 10%. I then pay 25%. Between 10 and 30 grand, so that's 20,000. Now, that's still easily me at the moment, isn't it? Because so far, I've accounted for 5, 15, 35,000 pounds worth of money. So if I've accounted for 35,000 or euros worth of money here, then I've still got, how much left to go? I make that another 20,000 euros to go. And this is taxed at 50%. Okay? I misread something there, it's 25% there. Okay? So to work out the amount of tax that I need to pay, I would do 10% of 10,000, so that would be 1,000, plus 25% of 25,000. Now 25% is the same as a quarter, so half of that must be 10,000, and then half of that must be 5,000. And then 50% of 20,000, let's make sure that looks like a 2, that would be 10,000. So the total amount of tax payable was 16,000 euros via the yellow party. Okay? Via the orange party, same sort of method, euros, 55,000 euros. And this time, I'm told that you get a much bigger personal allowance, which is great. That means I don't have to pay quite as much tax on the first. I don't pay anything on the first bit, which is great. It means at 0%, I don't have to pay them anything at all. It then tells you that 20% on the next £20,000. So that's much higher than the 10%, isn't it? So that's how they're sort of trying to work this out differently. And then it says a 40% on everything else. So I've accounted so far for 30,000 euros here. So that means that there must be 25,000 euros left in my pot. And that's going to be taxed at 40%. Okay? So 0% of the first bit, that's fine, we don't pay any tax on that. 20% of 20,000, well 10% would be 2, so 20% would be 4,000. Plus, and then 40% of 25,000, well 10% would be 2,500, so 40% would be 4 times bigger, so that's actually going to be 10,000. So the total amount there would come to 14,000 euros. So which party would be the best one for them to choose? Orange by, what's the difference between 16,000 and 14,000? By 2,000 euros. Okay? Next question, part B. It says Sam plays for an international rugby team. He is likely to earn 200,000 euros in the tax year 2018 to 2019. Without calculations, explain why he would favour the Orange Party. Well, purely because they charge lower amount on high salaries. So as Orange, still can't spell the word orange, as Orange Party taxes 40% on high salaries, compared to 50% by Yellow Party. Something to words of that effect. Okay? Next question. This question I felt was a bit fussy. You know, I did think you could take a long time doing stuff here. The way I did it, and I'm going to try and explain the steps. It's not an OCW question though, so you wouldn't need to explain every step. I'm going to explain every step just so it's nice and obvious what I'm asking you to do. Okay? We've got 64,000 papers. We're going to divide that by 10 because it takes 1 hour to mark 10 papers. That gives me 6,400 hours of marking. That's what that is, okay? Next, we've got a team of 50 examiners. So my 6,400 hours of marking divided by the 50 people, the 50 markers, I need to work out that. So I'm going to cancel 0 top and bottom there. How many 5s go into 640? Well, we're going to do bus stop again for that. That's come up quite a lot in this paper. How many 5s go into 6? 1, remainder 1. 5s into 14, 2, remainder 4. How many 5s into 40 is 128. So that is telling me that is 128 hours of marking per person. Okay? That's what I know that is. Now he's saying that we should get that done in 8 days. So if I do 128 divided by 8, what's that going to give me? So 128 divided by 8. How many 8s go into 1? None. Into 12, 1 remainder 4. And then 8 into 48 is 6. He's saying we're going to work 16-hour days. Now, let's put that into some relevance. There's 24 hours in a day. So you're going to go to sleep for probably about 8 hours. That's saying as soon as you wake up until you go to sleep, you are marking. You know, no one can do that. That's ridiculous. You can't do that, okay? So the only way that we could do that is if we worked 16-hour days. So it says, what assumption has the chief examiner made? You must show all your calculations to support your answer. Well, the assumption he's made is that people will work all day without breaks, you know, food, you know, even go to the toilet, nothing. You're working solidly from the moment you wake up to the moment you go to sleep. So that's what I've said. Why is the chief examiner's assumption unrealistic? What effect might this have on the number of days? Well, it's unrealistic because you need to have a break. Working day is roughly around about 8 hours. Working day equals 8 hours approx. It depends what you do. You know, some people do go and work really, really stupid hours. Be a teacher, trust me, we do way more than that. In terms of that, is unrealistic. So he's saying it's twice as much. He's saying work twice as much, 2 times as much. So in terms of what this will do to the marking, we can't work 16-hour days. You're going to work less hours a day. You know, it says 8. So if I halve the number of hours a day we're going to work, it's obviously going to make the marking time take twice as long. So it will increase the number of days to mark. The number of days of marking. Okay, something to words to that effect. Okay, then the next question. I felt this was a pretty horrible question. I'm going to try and put some numbers into this. Okay, so Greta has 50 empty jelly molds that she layers with red and green jelly. Each jelly mold is shaped in an inverted hollow cone, height 15 centimeters, which we've already put in for us, and volume 540 centimeters. Okay. She then begins by making 1 litre red jelly. Now watch out for this in the numeracy paper. We've given you predictions, so we thought this was coming up. You've got to know this conversion. Okay, so 1 litre is equal to 1,000 centimetres cubed. She pours it with equal amounts into 50 jelly molds. So we want to do 1,000 centimetres cubed divided by 50. So then 0 top and bottom there, 5 is into 100 equals 20 centimetre cubed per mould. Okay, now I think you'd be rightly expecting to go and do some work with cones here, but you given talking about volume and stuff like that, what you didn't probably realise is that this is actually similar shapes. So if we look here, we've got a cone there. They share the same height, goes to the middle, there and there. Okay, it's actually a similar cones question. So what you need to do, we're working volume here. We know that the small times by the scale factor cubed is equal to the big volume. Right, do we know what the scale factor is? I don't think we do, so we do need to do a bit of work with the volume as well. Okay, so the small one, which I don't know, I do know that, is 20 times by the scale factor cubed is equal to the big, oh no, I can work this out, is 540. Okay, now that comes to the scale factor cubed. So that means that if I take the times by 20 over, I'm going to get 540 divided by 20. So that gives me scale factor cubed equals 27. So then the scale factor is the cube root of 27. So the scale factor is 3. Okay, so I know that within here it says calculate the height of the red jelly in each of the moulds. I know all of this is 15 for the big thing. So then for the small thing, it must be a third of that. The scale factor is 3. So to find the height of red jelly, is equal to 15 divided by 3, which equals 5 centimetres. It's not a nice question. It's a nasty question. You've got to make sure that you're happy working with similar volumes, similar areas, all those sort of things first. And it didn't really tell you anywhere that they're similar. They're just assuming that you would spot that. Okay, so quite a nasty question. Okay, question 11, stratified sampling. What we must do to any stratified sampling is that we must add up all the numbers together. So we've got 128 adults, so I'll put the biggest one at the top, 73 and 39. That's a nice thing to put it in reverse order for us there. Add those together, I get, what am I going to get? I'm going to get 240. So we know we've got 240, and then from here, I want to turn the 240 people into 40. So I want to divide that by 6. Okay. Now it says, find out how many school children should be selected. You must show your working. Well, school children, how many secondary school children was 73? So I want to do 73 divided by 6. Okay, so again, bus stop coming up again here, 73.00, just to start working it out. 6 is in 7, 1, remainder 1. 6 is in 13, 2, remainder 1. How many 6s into 10? 1, remainder 4, and so on. So 12.1 children. So therefore 12 children. Okay, so that would be enough to get my marks there for what I've done. Question or part B says Rodri calculates seven primary school children should get selected. Rodri selects the first 7 primary school children to get off the bus that brings them to the concert. Explain why this does not represent a random sample. Well, think about it now. If you went on the bus, who would you go and sit next to? Your friends. Who's going to have the same opinions as you? Your friends. So if you were the first 7 people off that bus, then you could just be given exactly the same opinion. That's one way of saying it. You could also say that the school has been really, really organised, put them into alphabetical order. You could have 7 brothers and sisters, or 7 triplets, or something to that effect. You could get a lot of family members within that first people coming off. Again, who's likely to have the same opinions as you? The first 7 people on the bus, if they all have the same surname. Okay, so why does this not present a random sample? Maybe sat in friendship groups. That represent or that have the same opinions. You could also have had it as oldest and youngest, and then the older people are going to maybe think one thing, younger people maybe think one thing. You could also do it sort of boys and girls. So again, it could be lots and lots and lots of different ways here. Part C. Of one of the 128 adult performers, 52 are male, 76 are female. Gwen decides to interview a stratified sample of 16 adults and has 16 copies of the questionnaires. Using these numbers, she calculates that she should interview 7 male performers and 10 female performers, making a total of 17 performers. Explain how that's happened. Well, you saw with my answer a second ago that I got the answer 12.1, and I've rounded that to 12. Okay? If it had been 12.5, I would have rounded 13, but they probably would have given me one of these, giving like an answer 0.5, and the 2.5s would have rounded up. So that's what I'd expect to happen. So you've got to watch out for that. If that did happen, I would pick an extra female rather than an extra male to make sure it did add to 16, because there are more females overall. Okay, I'll maybe use logic like that. So it could have given answer with first decimal as 0.5, rounding both numbers up. Okay, that's what I would have expected to have happened. Okay, question 12. Anwin is designing an indoor play centre. This is the room. Anwin measures the vertical height of the room to be 5, so I'm just going 5 metres there, 5 metres. She measures the distance along the floor from E to F, so E to F from there is 12. I'm actually going to write that by there because that's obviously the same length. And then the distance from E to G, okay, so this is like diagonal by here. I'm going to go and draw in the diagonals and make my life a bit easier here. And she works that out to be, oh hang on, that's not 12 at all, that's 9 metres, sorry. E to F is 9, and then E to G is 12 metres. Okay, so she says, Anwin is thinking of purchasing a long straight slide for the play centre. The total length slide, including space to get on and off, is 12.5 metres. Would it be possible to fit the slide into the room? You must show some working for your answer. Okay, so it obviously won't fit at the moment because 12.5 would go like it doesn't actually fit along the floor. But you wouldn't want a slide to be flat along the floor anyway. You want it going like from the top to the bottom, wouldn't you? Now, my chances are that they're probably not going to fit along this wall, but it could do. I could do 9 square plus 5 square and see if it would work along like one side of the wall. But the most amount of space would be going from here, from A to G, here, from the back corner to the very front corner here. So that's 5 metres there. We've got a right angle triangle there, believe it or not, and then the base is 12. So to work out AG squared, that would be 5 squared plus 12 squared. So AG squared would equal 25 plus 144. So AG is equal to 169, but I've now taken the squared over to square root, and because I know my square numbers up until 15, I know that's 13 metres. So the answer is yes, there is enough room. Yes, enough room through the diagonal of the room. I think it's pretty clear, I mean the diagonal as well by saying AG. Through the diagonal of the room. And then, yeah, that's it, that's answered. Okay? Okay, the next question here was about histograms. I might have to stop in a second. I'll try and blast through the last two questions now very, very quickly. Okay, it says calculate the number of offices available with floor greater than 75. Now, think about it. We're on question 13. There's no way that I could say, 75 is clearly here. 4 add 6, add 9, add 2, 4 add 6, add 9, add 2. It's not going to be as easy as that. It's a histogram. It's got frequency density. You need to know this formula. Frequency density is equal to frequency divided by class width. I want to know the number of. The number of is what I call the frequency. So I want to rearrange that to frequency density times by class width is equal to frequency. This class width goes from 75 to 100. Times that by 4 would be 25 times by 4, which is exactly 100. This class width is also 25, but the frequency density is 6. 25 times 6 is 150. This would be 7. And then again it's 25 times by 7, so then add 25 onto that would be 175, and then finally this is a class width of 50 times by 2, which would be also 100. Okay, so more greater than 75 would be 100, add 150, add 175, add another 100. So 100, 200, 350. Careful now, I'm not going to fall for the mistake that they want me to make. So 350, add the 175, comes to 525, 525 offices. Okay? So don't try and do everything in your head. You think you might need a little bit of help. And then it says, part B, it says, office space charges £200 arrangement fee when any of the offices with floor space of up to 100 metres are let. Okay, well that's annoying because they didn't help me out in the last question. How many people are in here? I'm assuming that's one there. Yes, it is. It's 1. So that is a class width of 75. 75 times 1 is 75. So up to 100, 75 offices and another 100. So there's actually 175 offices. Just write that down. Offices up to 100 metres squared. So I get 175 times by, I charge 200 quid every time I let out one of those offices. So 175 times by 2 would be 350. And then add these two zeros here, 1, 2, comes to a total of £35,000. Okay? Part C's. I said here, so it says there are definitely no offices less than 10 metres. That's false. We can't tell that in a histogram. We just know that somewhere between 0 and 75 in that first bar it could be. There is one at 10. You doubt it, but I'd assume that. The modal would be the one with the most amount, so 175, that's between 100 and 125. 100, what did I say? 125 and 150, sorry. Yeah, that's what they said, that's true. The number of offices over 100 metres is double the number of offices under 200 metres. That's false, we just worked out all the numbers. There's enough information in the histogram to allow us to calculate the exact value for the mean. That's true, but it's a pretty nasty question if it comes up, because we know what all of the numbers are, and we can work out where they are. And then finally, the number of offices under 50 metres squared is definitely the same over 175 metres squared. So under 50 would be 50, I'd assume that, 50 times by 1, and then what they're saying? Over 175. Over 175. Well, again, you would assume 50, but we don't actually know the distribution within these bars, so that's not strictly true, okay? You could maybe assume it, but you'd be wrong to assume it, okay? It's actually false. And then part D, it says there are 600 offices. There are 600 offices. Sorry, I'm reading the wrong thing here. It is reported that the median size of the office space available to let is 80 metres squared. Is this true for the offices that are available let by Office Space Wales? Give a reason for your answer. Well, there were 600 offices in total. I know we worked out 525 before, but remember that didn't include the first bar. That was adding another 75. So 600 offices in total. That means median is equal to the 300th office. Okay. Now, if I go and look for the 300th office, 75, 175, I'd be 125 into here. Now, that's way over 100, isn't it? I'd assume that's getting closer towards the 125 than the 100, okay? So I'd actually say no. No, as it is the 100, sorry, you can't see what I'm writing, it is the 125th office, it is the 125th office over the 100 metres. You know, and that's way more than 80 metres squared. Okay. Final question. It says, David is an engineer working at the Welsh Science Research Centre. During the experiment, David knows that a certain chemical particle loses half its mass of the initial thing every 80 grams. The initial mass is 80 grams per second. After 8 seconds. Now, the way that I would work this out, I would say it's going to be 80, then it's going to be times by half, times by half again, times by half again, times by half again. Well, okay, times by that to the power of 8. 2 to the power of 8. Now I'm just going to write down the 2's going down the page. So 2, 4, 8, 16, 32. So I'm just doubling the whole time here as far as I can go. So I could keep on going here. I'm not going to bother though because I'm looking for the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. That's that one. So that would be 80 times by 1 over 256. I'm then going to just keep on repeatedly halving this. So 40 over 128, 20 over 64, 10 over 32, 5 over 16. Now, in terms of 5 over 16, sorry, in terms of what that is, that's very, very, very close to 5 over 15, which is a third. So it's got to be the closest one to 0.3 reoccurring, which is that one. Okay, that's me sort of trying to save a little bit of time when doing this question. It then says, comment on the mass of the particle after a long time, such as a whole day. Well, it'll be almost 0. I think the word they were putting in the mark scheme, which a lot of you seem to know from science, was negligible, but I'm not certain on that word. Okay, but I said it will be almost 0, if not 0. Okay, and that was the numeracy paper.